Okay, so I had a couple questions about this example on the notes, and so I wanted to run through this for you. Again, it was discussed in one of the color videos that I posted for you, but I'm going to go ahead and explain it in a little bit of a different way. Maybe it'll make more sense for you. So the example says, what is the rule for a yellow shirt? Again, the rule means what does it do under white light? So remember that the reason why we see it as yellow is the first part of the rule, and that is that it reflects what we see. So if it's yellow, if we call it yellow, that means it reflects yellow. And what is yellow made up of? Remember that yellow is red and green combined. So what our yellow shirt is doing with white light, remember that white is a combination of red, green, and blue. So if we're reflecting yellow, that means we're reflecting these two from the white. So what's happening to this part of the white? Well, if it's not being reflected, the only option is that it's being absorbed. So it absorbs blue. This tells us what the pigment in that shirt does. If red light is present, it reflects it. If green light is present, it reflects it. If blue light is present, it absorbs it. That is what the dye used to produce that shirt does with those three primary colors of light. And that's all we need to know to be able to answer the remaining questions. Okay, so what color would this shirt appear under red light? Well, all we have to know is that now the only color we have is red. We no longer have all three colors. Okay, so these colors are now gone. We don't have white, we have red. Okay, so all you have to do is look at your rule and determine what the pigment in that shirt does with red. Well, it says right here, it reflects red. There isn't any green, because we only have red light in the room, so it's not going to reflect it. There isn't any blue, so it's not going to absorb anything. It's going to reflect the red that is present. So, what do we see? We see the color that is reflected. So in this case, the shirt appears red. Because the only thing being reflected is the red light. Okay? Now, let me not get past my rule here. Under a blue light, okay, so now the only light we have in the room is blue. So let's look up here at our rule. Is there any red light in the room? No. The only light is blue. So it's not going to reflect red. Is there any green light in the room? No. So what is it going to reflect? Nothing. The only two colors it can reflect are red and green, and the only light we have in the room is blue. So nothing is getting reflected, okay? What does it absorb? The pigment in this shirt absorbs blue. Do we have blue? Yes. So what happens to the blue? It gets absorbed. So we only see what's being reflected. Nothing is being reflected, and nothing is black. Okay, the absence of light is what we call black. If it's reflecting nothing, we're seeing an absence of reflection. That's called black. Okay? Under a green light. Okay, so now we're in a dark room. We have a green spotlight on our yellow shirt. Go to your rule. What does the pigment in the yellow shirt do with green light? Okay, so no red in the room, so it's not going to reflect red. We do have green because we have a green spotlight, so it's going to reflect the green. What does it absorb? This dye only absorbs blue. Do we have any blue? No, because we have a green light, so it absorbs nothing. We don't care because what we see is whatever is reflected. So it reflects green. So to us, the shirt appears green. So this is one of the reasons why, if you are working in live theater production and you are using spotlights, you have to be really careful about turning off all of the white light and only using a certain color spotlight. Because if you're only using a certain color spotlight in a completely darkened auditorium, it can actually change what color the costumes and the sets are appearing to be on the stage. So this is not just something that we're talking about in physics. This is something that has actual practical applications in theater and movies and television and all of these things. We have to be very careful about what color lights we're using, especially if we're using them in the absence of white light, which contains all of the colors, which is how we're used to looking at things and how our clothing and our paint and our furniture and all of these things are colored based on what they do in white light. Hope that helps.